Hello once again, AP Calculus students. Mr. Record here from Avon High School. Welcome if you're watching this from outside of Avon, but if you are an Avon High School student, you are probably looking at your notes from section 4.1, talking about anti-differentiation, and this is the last example, number 6. And this is going to be a very short video that just introduces basically two formulas, and I'll show you how you can use these formulas in a very easy application. It's very important to note, and I'll state this probably numerous times, I'm not going to prove these integration formulas in this video because they require knowledge of a future topic that I'll cover in a subsequent video later on. So with that said, we're going to go ahead and take a look at our first application, the integral of the natural logarithmic function. And it's a little misleading here, and I think I might want to make an adjustment here where it begins to saying let u be a differentiable function of x. That is certainly going to be the case here later on when I change that exponent from being an x to possibly being something that's a little bit more robust than an x. Maybe it'll have a coefficient in front. Maybe it'll have an exponent attached. It could have a variety of things that would modify it. But for right now, we are just going to focus only on the integration of e simply to the x power. And as you can see from the formula, it probably results in something that you anticipated, e to the x plus our constant. Now, if you recall, if you're watching this video, you probably have already studied the derivative of e to the x with respect to x. That's what we like to call the easiest derivative formula in all of calculus, because the answer is indeed just e to the x. So using that piece of knowledge, if you integrate something that's got a coefficient 5 in front of e to the x, we know that we have a property that says we can pull out any constants, and then we just integrate our e to the x like we would, getting an e to the x, and then we just tack our constant on at the end. It's really that simple. Things won't get to be a little bit complicated until we revisit this idea of the u and we perform what's called a u substitution. That will be coming up in section 4.5 with my particular students. And then lastly, we have the integration formula for bases other than e. So yes, you can certainly encounter situations where you're wanting to integrate, say, 2 to the x power, or maybe 5 to the x power, all of which would be with respect to x. Things like that. So we have a different formula. You cannot rely on the same formula over here because the base a is not behaving the same as the base e. And you can see that it's a little bit more complicated, especially in the fact that you've got this 1 over natural log of a component in front. Obviously, we multiply by a to the x power, and like always, you have your plus c constant. Now, if you recall, let's go back to the days that you were taking the derivative. In a situation where you have the derivative of a to the x with respect to x, that result was the natural log of a times a to the x. Now you see that there are some common characteristics between the integrals answer and the derivatives answer. Well, they each contain an a to the x, but the primary difference is the presentation of that natural log of a. So you want to keep in mind that in the integration setup, that particular value is going to be reciprocated. And I have a video that I'll show later that kind of proves how that comes about. But I think as far as just a simple memorization technique, think about the integral as reciprocating the natural log of a. Now, another thing to think about, could this be modified and look a little bit like our integration of e to the x? Well, that is 100% the case. Because if we think of this base as being e, and we write the formula with our integration for bases other than e approach, we're going to get 1 over natural log of e times e to the x plus c, and of course the natural log of e we know is 1, so we end up with the e to the x plus c that we should have had over here. So these two formulas really aren't all that far apart from one another. Now, as far as how you would use this in an application, You can see here that the integration of 6 to the x power is as pretty basic as we can see. So we just simply apply the formula, knowing that the a value is indeed 6. So we begin with 1 over the natural log of 6. That's a very ugly, irrational number, so we're going to leave it like that. And then we just multiply him by a to the x, which in this case is 6 to the x power, and then we add our constant. And that's it. You don't have to simplify. You don't have to rewrite in any way. So you're going to have some practice here with some very, very basic versions of these integration formulas. And then we'll ramp up the difficulty by changing these exponents, x, to be something a little bit more complicated. Anyway, I hope this helps, and we'll see you at the next video.